Hello there, math analyzers, and welcome to your Chapter 1, Lesson 2 notes video. You will notice that I am not in my classroom currently. If you see me with this kind of background, the cherries and the plums, and what are those, peaches, right? This is my dining room. One section of my dining room anyway. Back corner. Okay, so here we are. There's also a cat down here. This is Ray Ray. Ray, say hi to the people. Okay, she's in a mood. Well, anyway, we're going to talk about identifying types of functions and relations. And again, I'm saying talk because it's me just talking through what's already written out in the notes. It probably won't take very long. A lot of this is review. So we'll just kind of get through this, go through and see what we got. And maybe this, ooh, look at that colors of highlighters. Maybe this one will be a little bit nicer because this is, I'm opened my PDF in Read and Write. So I'm hoping to be able to kind of use this a little bit better than I've been able to use um, the writing tools that came with Screencastify. So here we go. All right. Part one is relations and functions. Cool. Well, we just talked about those, right? A relation is any set of points, and a function is a set of points that does not have an x value repeated. So we're looking at two pictures, and they look very familiar to me. We had that exact picture in lesson one. So function, no x values repeated. Relation, x values are repeated, and it fails the vertical line test. All right. So some of these things that we're going to be talking about are functions. Some of them are relations, and some of them have both options. Okay. And we'll talk about that as we go through, right? Because cube, no, I'm not thinking of cubes. I'm thinking of square root can be functions or relations, and lines can be functions or relations. So that's actually where I'll start because that's the easiest one. We know both most lines are functions, right? So most lines pass the vertical line test. Here's a positive sloped line right here. And here's a zero sloped line or a horizontal line right here. Here. Let me see. Can I write? Click to speak. Screenshot. No word selected. Freehand drawing. There's a negative sloped line that becomes less of a line at the end, right? But that's it. That's what we're talking about. Oh, there we go. Cool. Hey, this thing is kind of neat so far, right? But you also have lines that are not functions. This is a vertical line, and it is not a function. Vertical lines, is that how you highlight? That's how you highlight. Okay, cool. Vertical lines are not functions because they fail their vertical line test. And actually, it's because their x value repeats infinitely in both directions. So that's the reason that it's not a function. So that's the only type of linear relation is a vertical line. All other lines are functions. Absolute value functions are always functions. They really are actually a line that then has like a cut almost. It's almost like a piecewise function of two lines that meet at a vertex. And then its slope just goes in the opposite direction. But these are the A's and the V shapes, right? And as we go through, so like I know this in particular. Oh, I can answer back. Okay. I wanted it to read it for me. Hold on. Let's see if it'll read it for me. Okay. I guess it's not going to read. Bummer. Whoa. Well, that's neat. Some neat stuff on here, huh? Speech. Okay, anyway. All right. Absolute value functions. This is the general equation. This is an like the parent function of an absolute value, the most basic absolute value function. These guys have vertexes moved around in the coordinate plane, but we'll talk about that when we start graphing all of our fun stuff, which we will do very soon. Quadratic functions, aka parabolas. So maybe you've heard of parabolas before. Ah,
Parabola.
how fun! How fun is that? There he is. Good old parabola. All right, well, anyway, quadratic functions are also known as parabolas. We will look at two forms of their equations, either the vertex form, which is this one right here, looks very similar to the absolute value form that has a vertex too, right? These guys have a vertex. They have very similar forms. And this is like the standard form of a quadratic function. We'll talk about both of those actually when we graph quadratic functions. We'll do that a couple times. Sorry, Ray. Here's your classic parent function for a parabola, right? But smiley faces and frowny faces is generally how I talk about parabolas. So square root functions,
Of. To. Of. There.
I just wanted to get rid of it, but okay. It really will read everything. Cool. Square root functions or square root relations. So if you only have one half of the flip of a quadratic function, then you have a square root function. So I only have half of that flip. It stays function form because no x values are being repeated. But notice this is a relation where it has the plus and the minus. So when I'm taking the square root of an x squared, right, typically a plus and a minus come out. But this only happens if you have that plus and minus in front. That's when it's a relation. In the x values, I'll show you, right? Fails vertical line test. X value gets used more than once. There we go. So, well, doing it again.
Be.
Doing it again. I don't want you to speak right now, dude. I'm scrolling down. Weird. We'll just go to highlighting, right? Exponential functions. Yeah. Heard a lot about those lately in all the modeling stuff. Exponential functions are functions that have an extremely rapid increase or decrease. The rapid decrease is typically when you have a number between 0 and 1 as your base. And the rapid increase is when you have a number greater than 1 as your base. You've heard a lot about exponential functions as they've talked about modeling, virus predictions and stuff like that, like virus infections, who's going to get infected and how it's going to run through the population. That's been exponential models. That's how it works. I mean, if one person gets two people sick, then those two people get four people sick, and then those four people get eight people sick. And you can think of it very simply that way, even though it's not as simple as that, it's slightly more involved. It can be thought of um, as how quickly that type of thing can spread. So, oh, cubic functions. Okay, so these guys look like vertical snakes kind of going up your graph this way. This is a very basic cubic function. We're not going to deal a lot with them. We really just need to be able to recognize them and graph them if we're given them. It's not anything nothing intense. We might have to do a couple of factoring of some cubics, but we'll keep it pretty basic in this course. Cube root functions, same thing. We're not going to have to take any cube root functions. We might have to graph a couple because this is expected in algebra 1 and algebra 2 is just that's just a plug into graphing calculator and graph the points that you get. Actually, same kind of thing with step functions. These are the notations for step functions. Hands on the ceiling or feet on the floor is how you can think of it. These are rounding. This is greatest integer, is least integer and greatest integer is how these are also referred to as this notation. You're rounding down or rounding up is what you're kind of looking at for these, for things like these. Okay. You really just need to be able to identify these. It's not going to be a huge deal. Also, I will show you how to evaluate using these. Okay, so like if I plug a number into that, I'll show you you round up when you got the hands, you round down to the lowest integer when you got the feet. That's really it. Piecewise functions, more than one piece with a y or, or an f of x, that's going to be a piecewise function. So here's a piecewise function where there are 1, 2, 3, 4 pieces. And I say 3 because this one point down here is the point. See how those are both open circles there? That's nuts. There are 4 pieces on this. It doesn't relate to that function right there. This one only has 2, right? So that one's a little bit more straightforward. Okay. Oh, excuse me. Cat's sitting here purring, making me tired. Circles. You did a lot with circles last year in geometry. So circles, this is their center form, right? So center and radius form. This is your center value, x value. This is your center value, y value. And then your radius, take the square root of this. That's your radius. So in this particular case right here, the radius is 2 comma -5. So this would be x minus 2 in parentheses squared. Can I write? It's going to let me write. Oh, the writing is terrible. Plus. This will be y plus 5 because the -5 is the y value of the point. So it's the opposite sign is what's inside the parentheses. Oh, wow. Now that's a parenthesis for you. Equals, well, let's see what's the radius. 1, 2, 3. So the radius is 3 squared, 9. There you go. That would be its equation. Sorry that that's the sloppiest ever. But that's it. Loving this. Okay. Again, why do we mention some things are functions or relations? We just need to be careful because obviously if I only have half of this square root function, then it's still a function. But if I have both pieces of it, it's no longer a function because x values are repeated. All right, so that's why the plus and minus together is in front of a square root symbol. That's creating not a function anymore. All right, now we're going to talk about evaluating. So if you're evaluating from a picture, what you do is you look at the point on your function, and its x value is always its input, its y value is always its output. So if you're asked to evaluate f of 2, you come to positive 2 here, come up to where that point touches your function, and you find its matching y value. So in this case, f of 2 equals 1. So let's do a couple more down here. Okay. J of -1. Well, here's -1. Head down here. Here's the point where it touches the function. And that also has a matching y value of -4. So J of -1 equals -4. All right. G of 4. So go over here to 4. Here it is. Find where it touches the function. That's right here. That has a matching y value of 1. So G of 4 equals 1. Okay. Here's some practice evaluating, right? G of negative 4. Well, negative 4 is right here. G is right here, right? So G of negative 4 equals 2. Negative 2, excuse me. Go. G of 0. Okay, so here's 0. We head up to where it touches, and it touches at positive 2. G of 4. Here's 4. Head down to where it touches. Looks like it touches halfway between negative 2 and negative 4, so that'd be negative 3. Here, let's see, G of 8. So here's 8. Head down to where it touches. Oh, it touches at negative 8. And down here, G of 12. Here's 12. Where's 12 touch? Oh, 12 touches right there at positive 8. I need your box down here. Excuse me. There we go. Let's scooch this guy up. Hey, there we go. Cool. Okay. Let's keep going. Really likes to say that. Evaluate the function h of x for the given values. Oh, okay. So I'm going to plug this in for the parabola and then I'm going to solve it, right? So h of 2. Okay, so let's see. Let me use a text box. H of 2 equals 2. Nice square. Can I use math type? Where's my math type? This is supposed to have that. Okay, well, let's do this. 2. Where's my caret? There it is. Minus 3 times 2. That caret is meaning I'm squaring right there. Minus 3 times 2, that's multiplying. Minus 4 at the end. All right, so let's see. This stays h of 2 on this side because our input is the same, right? So first we think, what's 2 squared? Well, that would be 4. Then we have negative 3 times 2, that would be minus 6. And then we're subtracting 4 from that. So 4 minus 6 is negative 2. Negative 2 minus 4 is 6. Okay. I put that here. So that's right under this particular problem. And then I'll use this one up here for negative 2. So let's try h of negative 2.
H.
Hey, back off, lady. So now we're negative 2 squared minus 3 times negative 2. So that'll be interesting right there because that's negative times a negative. So h of negative 2. Okay, well, negative 2 times negative 2 is still positive 4. But this time, negative 3 times negative 2 is a positive 6. So those are actually going to end up adding. And then we have that minus 4 at the end. So 4 plus 6 is 10. 10 minus 4 is 6. Last but certainly not least, if you have a polynomial input. Okay, and so I'm going to show you how this works. Okay, so that's going to be my polynomial input. I am going to replace where x was with that whole thing. So this is going to be x plus 2 is squared minus 3 times x plus 2 and then minus 4. Okay, so when you square a polynomial, it's the polynomial times itself. Foil. I'm going to have to foil that. Okay. Then let's distribute the negative 3. So negative 3 times x is negative 3x. And negative 3 times negative 2 is negative 6. And then you've got a minus 4 at the end. So there's a couple of things there that those guys are going to be able to combine as far as like terms go. Okay. Um, let's FOIL. X times X is X squared. X times positive 2 is plus 2x. And I do that again. So another plus 2x in the middle. 2 times 2 is plus 4. And now I'm just going to bring down all the other guys that I've already had but haven't used yet. And now let's combine everything that we can combine, right? The like terms. So there's nothing else that's like, wonder if I can pull this out. Oh, look at that. Nothing else that's like the x squared. So that's going to come down to this last line here. Now there's a 2x plus a 2x minus a 3x. 2x plus 2x is 4x. 4x minus 3x is a positive x. Positive 1x right there. Sorry, I didn't mean to capitalize that x. Now with numbers, let's look. Okay, so we've got 4 minus 6. So 4 minus 6 is negative 2. Negative 2 minus 4 is minus 6. And there's our answer. Okay. That's how that works. Rarely will you be asked this, and I do not believe so on the homework. Let's just take a peek because the homework is right here. Then matching, matching, matching. Okay. Evaluating. Here we go. So I don't see any polynomials being evaluated here. I will say I do not want you to do number 41. Okay. So number 41 is evaluating in a circle. And I would very much prefer that you not do that right now. Okay. Evaluating in a circle. No shot right now. Just want to double check, make sure there's not step 2. Do not see a step function. I think everything else is one you can handle. Fantastic. But please don't worry about plugging into a circle. So you don't have any polynomials to evaluate in as far as your inputs, and you do. I don't want you to do number 41. It sounds like there's a lot of questions. I mean, I know 41, right? Sounds like there's a lot of questions on this homework, but it's matching, 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 matching. Like the right one. This doesn't even have all of the options. There's only a few options there. Okay. And then actually plugging in and evaluating. Now, you can do a lot of this evaluation on your graphing calculator screen. Okay. So that also wouldn't be a problem. I'm not looking for you to show me all of the work for that. Okay. So I'm just looking for what's the output for those things. So you can do that on the graphing calculator as well. All right. I wish they had mine on my, they haven't put my graphing calculator on my laptop yet, so I don't have it to show you quite yet. But as soon as I do, I will show you exactly how to plug those fun guys in. Okay. Well, yeah, this has been fun. I've been learning read and write as we go. Very interesting. Okay. Well, guys, enjoy the all the matching activities here on the lesson 2 homework, and I shall be seeing you. Bye.